This question is an electric field question from the new syllabus. Okay, so if you're wondering what the changes between the new and the old syllabus is, a lot of the focus for AS level electric field is on kinematics. We study stuff like what's the final speed of the electron at this point in the plate, what's the initial speed, yada yada. Okay, but for A level or A2, the focus is on fields and forces and also on energy. All right, so let's look at this question, see what we can learn by answering it. So this part here, it says state what is indicated by the direction of the electric field line. So normally, when we draw a field line, it always shows the direction of force, because force is part of the field. If there's no field, there's no force. Okay, so it's always a part of the field. Just remember that. Anyway, in this case, in this question, we're going to say that the direction of electric field line is the direction of electric force. And remember, we always define electric force on a positive charge. On a positive charge. So our reference charge is always positive because it is written that way by Coulomb. He decided that positive is the way to go. So if you mention that it's the direction of force, this will be 1 mark. And you mentioned that the force is acting on a positive charge, this will be the other mark. Nice and easy, bonus. All right. So here is a parallel metal plate, and it shows up here 2400 volt, down here 0 volt, and the gap is 4.6 in. Plates are separated, and the plates are in vacuum. On the diagram, draw 5 lines to represent the electric field between the plates for 3 marks. Okay. So when we see parallel plates like this, metal plate, or recall that this one is uniform field. Uniform field means you will have parallel lines with equal separation. So you want to draw 5 lines like this that are equal, that have equal separation. Of course, if you have a ruler during the exam, that will be great. Now, I will measure the length, I will divide by 5, then I'll just draw the lines. But now I don't have, I just roughly only. So normally I draw the center one first, and then I try to like gap equally on both sides. During the exam, please don't judge by eye. If you can use the ruler. If you draw 5 lines, this is 5 lines is enough for it. If I draw more than 5, can I? Sure, can draw more than 5. Does this make you happy now? You happier now? So you make sure that the gaps are equal. The examiner won't really take a ruler there and measure, but judging by eye, it should look equal. Okay, so this is the direction that has to be same as the direction of force on a positive charge. So imagine there's a positive charge here. Where would it go? It will run away from the positive plate, right? Because this positive 2400 means this plate is very positive. Up here is very positive. So this electron is going to be like, nope, no thank you, and come in this direction. So this is the direction of the electric force, meaning the direction of your electric field lines must be pointing here. You draw at least 5. You don't draw this one and this one. It's okay. You draw also okay, no problem. All right. You leave the charge inside, also okay. You want to rub off the charge, also okay. All right. So a few ways to draw the direction of the field lines. Number 1 is parallel to the direction of force acting on a positive charge. And another way to double check is that the direction of the electric field must flow from high potential, positive 2400 volt, to low potential, 0 volt. Okay. All right, we're done. How do we get 3 marks? Well, 1 mark is when you have lines that are perpendicular to the plate. So we're talking about the shape of the lines. Direction, don't care. Okay, so the shape of this line is perpendicular to the plate. So 1 mark. Okay, the second mark is I have 5 lines perpendicular to the plate and uniform spaced. Okay, and the final mark is when you have the arrow pointed in the right direction, downward direction of arrow. I like this question. It's a very easy 3 marks. All right. Then we part 2, calculate the strength of the electric field between the plates. So if you think about the strength of electric field, okay, E is equal to V over D for a parallel plate or uniform field. Parallel plates. So 2400 separated by 4.6 cm. This would be 5.2 times 10 to the power of 4. Nice and easy. This page all bonus. 7 beautiful bonus marks. Come on. Equation is 1 mark. Substitution, C1. Substitution leading to the correct answer is A1. Please show your substitution, okay? All right, all is good now. Let's look at part C. A moving proton enters the region between the plates. Okay, the proton is deflected by the electric field. On figure 4.2, draw a line to show the path of the proton as it moves through and out of the region of electric field. Obviously, the proton will be attracted to be pushed away from the positive plate and attracted to the 0 volt low potential. Okay. Another way to look at it is, let's say the proton is here inside the field. Okay. It will experience a force in this direction because proton is positive charge, right? Proton is positive charge. It will be pushed away from the positive plate. The top plate is positive. So it will push the proton away. Please go away. I don't want to be with you. I'm already very positive. So the proton will be pushed downwards. So when it pushes downwards, and it begins to move downwards, it is also having this horizontal component. So it's a bit like projectile motion. Think of your ball. If your ball roll off a cliff, let's say with the initial speed of mu is 10 meters per second, where would the ball go? Go like that, right? But teacher, why you go like that? Well, because no matter where the ball is, it will be attracted by weight or gravity. You see, weight and gravity is always pointing down because the ground is here. So you'll be turning in this direction. So likewise, you can say that your proton will turn this way. Do you need to draw an arrow? Nope. You don't have to, but it's helpful because they draw it. See, they draw, also draw. You can choose to not draw the forces. Okay. Also kind of electrical, right? You're like, teacher, does it matter how I turn or how fast I turn? No. It no matter. Okay. So I'm going to stick to my old one. Okay. Doesn't matter because you don't have any information and it's 2 marks. This line is 2 marks. Where are the marks? So 1 mark is for a smooth curve. Again, I'm writing on a tablet, so my curve is not that smooth, but it's okay. Okay. In field. But also at the same time, it says here, move through and out. Oh no. If they say out, is this okay? No. See, great question. Move through and out. So this means the move in a straight line. And then here it would deflect and go out higher. Steady hand with a steady curve. Turn and leave. Compass thing. But this is actually a parabola. Not a compass. Can I draw some? Parabolic. Okay. So turn and then out of the field. So I also need to draw a straight line here because it's going out of the field. Use your ruler Try to stick to the same gradient. Don't become steeper. And also don't become less steep. So something like this. So smooth curve in the field, preferably parabolic. And then straight line outside the field, outside the region of the electric field. Okay, because outside the region of electric field, there's no more electric force. Here you have force, you have electric force pointing in this direction. Okay, always 90 degrees to the plate one. And then after that, once you relieve already, there's no more force, so it moves in a straight line. Okay. The second mark is when the bend or the deflection is downwards. So this part of the question is essentially asking you to develop your understanding of motion of charges by considering the forces. We are not doing any calculation around how far, what's the length, what's the width of the parallel plate, what's the length of the parallel plate. That's not the concept. All right. Okay, part 2. We are now going to replace the proton with something new. And something new here is a helium nucleus. Okay, with the same initial part as the proton and traveling with the same initial speed. So this means everything is the same. The only difference is I replace the proton with a helium. Interesting. Stay and explain how the final speed of the helium nucleus compares to the final speed of the proton after leaving the region of electric field. So basically, they are asking us, will the speed of the proton and the final speed of helium, is it greater than, is it less than, or is it equal? Okay, so there are a few ways to answer this question. All right, to realize or to figure out what the velocity is, you have two routes to take. Okay, and I'll explain what the routes are. First one I think about is kinematics. Meaning I need to figure out what is the acceleration A. Okay, so the reason why the proton and helium is accelerating in the first place is because you have an electric force, so pulling it downwards, right? So you have this electric force, Fe pulling it downwards. So I have to figure out is Fe, compare Fe, electric force, compare electric force, then I can compare acceleration, then I can compare mass, because F equal ma, the mass of proton and helium are obviously different. Then I can compare final speed. So this is a way to go. Okay. Another way you could go is to think of conservation of energy. Okay. So for this case, I will need to compare work done by the electric field, and then I will have to compare the gain in Ke, and then I would then have to compare the mass. Then only I can compare final speed. Because if you think about it, move this a bit here. The reason why I want to compare this is because the electric force is equal to ma. So if I can figure out what is the acceleration, I can figure out what's the final speed. And the reason why I still need to compare mass here is because kinetic energy is half mv squared. Okay, so let's try the first one first. The first one feels a bit more simple. Think about that. So number one, I will say that the electric force on the helium. Helium has a charge of 2 plus. Proton has a charge of 1 plus. So obviously the electric force on the helium is greater, right? helium nucleus is greater because helium has double charge. You know what? Since I know double, I should also probably mention that the electric force on helium nucleus is double. Okay, because helium has double the charge of proton. Okay, what about the mass? Helium is 4 times heavier. So mass of the helium nucleus is 4 times greater than the mass of proton. So which one will have a larger acceleration? Electric force is equal to ma. This electric force can be written as QE is equal to ma. Right? So A, acceleration, will be QE over m. Why do I care about acceleration? Because I care about final speed. Greater acceleration, greater final speed. Okay, so that means for helium, although the force double, but the mass times 4 means the acceleration for helium is less. I have 2 times the force, but 4 times the mass. Make sense? So you can already see that the acceleration of helium will be less than the acceleration for proton. Or you can use this equation. Q times 2, but m times 4. That's why the acceleration of helium is less than the acceleration of proton. Okay, so I would just say that the acceleration, hence the acceleration perpendicular plates is greater for proton or smaller for helium. Since I start with helium, I continue with helium now. Is smaller for helium. Since the initial velocity, the initial speed is the same. Same. The final speed of helium is less than proton. Okay. So this one needs to plan out your explanation one. You won't be able to straight away just do unless you're really smart lah. Okay, so you got need to have a bit of strategy. I want to compare final speed. So I do a graph here. I want to compare final speed. So I guess I probably need to compare acceleration. And right now, 2 things are affecting the acceleration: the force and the mass. So I will make sure I compare the mass. I'll make sure I compare the force. So if you mention that the electric force is double, but the mass is 4 times, this 2 itself is already 1 mark. That means you know what you're supposed to compare. Okay? And then from here, you deduce that the acceleration is less for helium. This is 1 mark. And then you conclude, especially you probably need to mention the initial speed is the same. Because if the initial speed is the same, we also cannot say that helium is slower. Because the initial condition is the same, that's why we can say helium is slower, because the acceleration for helium is less. So finally, the speed of helium is less than speed. Okay. So when it comes to the compare question, whether it's greater than, equal, or less than, okay, there's always normally a few fundamental ways that you can go about it. Either previously there's some calculation that you have already done, that will be even better. So a better question would be actually me setting you up by asking you to calculate some of these values first. Then based on that, you can deduce. But I guess the question here is also testing whether you know what are the comparisons we need to make. Okay. So the second part here, is if you want to use conservation of energy, you can as well, but that will be. If you want to use conservation of energy, the equation that we are working with is the change in electric potential energy is the change in kinetic energy. So electric potential energy will be QV. Okay, V is the potential difference across the plate. And the change in K will be half mc squared. This V square is the speed. Okay, so right now, I can first do comparison about work done. Okay, so I would say that helium has twice the charge. And hence work done on helium by the electric field is 2 times work done on first point. Second point, we need to compare mass. Because work done on electric helium is 2 times. Then why we talk about Ke first? Gain in kinetic energy by helium is 2 times gain in Ke by the third step. Although helium got more energy, it has 4 times the mass. The problem is it's 4 times. Mass of helium is 4 times mass of proton. And because of this, finally, final speed of helium is less than proton. Okay, because if you look at this charge times 2, but this mass times 4. So finally, velocity of helium is still less than the velocity of proton. Also can. So the first two one, V1, and then you compare the mass and the final speed. Something like that. Okay, so either way is okay, but try to write something that you are confident with. And also because at the end of the day, this one got no guidance to direct your explanation. So what you're comfortable with is better, but they are both okay and possible. You can use kinematics or you can use conservation of energy. But the important thing is to plan out your answers first. All right, so you can see this question went from very easy to a bit more challenging because they're testing your ability to explain and analyze the scenario.